All right, Mr. Trutna here. This is assignment A. This is math 2. This is the green piece of paper that you were assigned to on Tuesday, August 20th, the second day of school. And what you had to do was you were assigned numbers 2-36, which we can see right here. And you're doing 2-36, and you're going to do numbers 2-36, 37, and 38. What I'm going to do is, you can't hear me talk probably very well. I'm going to turn off a couple of the lights here, so maybe, okay, that's a little bit easier to see. Okay, so let's go ahead and get started. So if you notice, and what I'm going to do is I'm going to try to jump back and forth between the problems from your paper and then what it should look like on your graph. So this is part A right here. You can see I already have my graphs made. So in part A, the idea was that you wanted to draw line A, and line A was supposed to go through. Here, let me zoom this in so we can see what's going on. Okay, let me focus it. Sorry about this. This is the first video I've made this year. Okay, so we need to draw line A. We're going to put it on graph A, and it has to go through the point 25. So the first thing that I'm going to do is I'm going to plot the point 25. So I'm going to start the origin. I'm going to go over 2. I'm going to go up 5, and I'm going to put a point. And then I'm going to draw a line. I'm going to label it as A, and it's going to go right through that point. Okay, so I'm going to draw this line right here. There we go. So that right there would be my line A. Now the question is that the only possible line that I could have drawn that goes through the point 25? Okay, if it is, if that's the only line that I could possibly draw, then I'm just going to stop and I'm going to move on and I'm going to do B. However, if I think there's more than just this line that I could draw through point 25, I'm going to draw another line. Okay, and you can see if I go like this, there actually is another line. As a matter of fact, if I could draw thousands, hundreds of thousands, millions of lines that go through this point. So A, if you did it correctly, if you understood the problem correctly, you would have drawn 2 lines, okay? They didn't have to look exactly like mine, but they would have both gone through that point, which had the coordinates 2, 5. Okay, so in B, you can see in B, we're going to draw a line. We're going to label it B. So we're going to put it here. It's going to have a slope of -3, and it's going to go through the origin. Okay, so to make this, the first thing that I'm going to do is I'm going to put a point right at the origin. And then from that point, I'm going to create a slope of -3. Well, remember, if you recall, slope is how much a line changes on the y-axis, which we put like this, over how much a line changes on the x-axis. So it's the change in y over the change in x. So if the slope is -3, I'm going to think of it as -3 over +1. So from here, I'm going to change on the y-axis for -3. That means I'm going to go down 3. And then I'm going to change on the x-axis +1, right there. I'm going to put a point. Okay, and then I'm going to draw a line that goes through the origin. You can see it's going through the origin, and it has a slope of -3. Okay, now the question is that the only line that I could possibly draw that goes through the origin and has a slope of -3, and that is the only line. So in B, you should have had one line, and it should have looked exactly like this. Now, the instruction said if you can only draw one and exactly one line, then you want to write the equation of this line. So if you recall from last year in Math 1, we write equations in the form of y equals mx plus b, where m stands for whatever the slope is, which in our case is -3, and b stands for what we called the y-intercept, and in other words, it's the exact number that your graph crosses the y-axis at. So here's my y-axis, here's my x-axis. So to write the equation of this line, it would be y equals m, the slope, which is -3, x, keep the x, plus, and b is where does my line cross the y-intercept at? It crosses it right there. What number is that? That's 0. So y equals -3x plus 0, or you could have written it as just y equals -3x. Okay, moving on to part C. So here's my graph for part C. Here's my x-axis. Here's my y-axis. And then what I needed to draw was I needed to draw line C, and it needs to go through points -3, -2, and +3, 10. So I'm going to plot these points. -3, -2 is right here. +3, +10, so I've got to go over 3 up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You may have to go off your graph a little bit. Okay, you can see I went off my graph. There it is. And then I'm going to draw a line C that goes through these 2 points. Okay, like this. So there's my line. Remember, whenever you draw a line, put arrows at the end of the line. Now the question is that the only line that I possibly could have drawn that went through both those points? The answer is yes. Okay, so right there is my line. Okay, now if there's one and only exactly one line, then you want to write the equation. So once again, I'm going to write the equation of the line in y equals mx plus b form. Y equals m. I need to find the slope. So in order to find the slope, what I'm going to do is I'm going to start and I'm going to make what's called a slope triangle. So my slope triangle is going to connect one point from the line to the other point on the line, and then I'm going to count my change in my y over my change in my x. So you can see my change in my y is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And my change in my x is 1, 2, 3, 4, 5, 6. So my slope is 12 over 6x. Then my b stands for my y-intercept. Where does my graph, where does this line, where does it cross the y-axis at? Right there. What number is that at? 1, 2, 3, +4. So we put +4. Okay, so that would be your equation. If we want to simplify this, 12 over 6 becomes 2x plus 4. That would be my equation. Part D of number 36. Here's my graph for part D. Here's my x-axis. Here's my y-axis. And you can see from the paper, part D says I'm going to draw line D, and it has this following table here. Okay, so what I'm going to do is I'm going to use this table and I'm going to plot points. The first point I'm going to plot is when x is 2, y is 1. 1, 2, y is 1. My next point that I'm going to plot is when x is 3, 1, 2, 3, y is 3.5. 1, 2, 3, and 0.5 is a halfway up. My next point is when x is 4, I'm going to go up 6. 1, 2, 3, 4 for x. 1, 2, 3, 4, 5, 6 for y. And then my last point is when x is 5, I'm then going to plot 8.5 on the y. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, and 0.5 is halfway up. So these 4 points are the points that I'm going to plot for D. Now the question is, can I make a line out of them? And you can see when I put my ruler down, I could connect all the 4 dots or points with the line, so I can make a line. Okay, then the next question is that the only line that I could possibly make that goes through all 4 of those points? And the answer is yeah, that's the only line I could make. So since that is, I'm going to write the equation. Y equals mx plus b. Remember, m is the slope, so I'm going to count from one point to another point, and I'm going to count from the first point up to the third point because I don't want to deal with the halves. So I'm going to make my slope triangle. Okay, my change in my y was 1, 2, 3, 4, 5. See, that's 5. And then my change in my x is +2. So I'm going to get y equals m is 5 over 2, x, and then b is my y-intercept. So you can see the way that I drew my graph, I didn't extend it long enough. So I'm going to have to take my line, I'm going to have to keep going until I find my y-intercept, and it looks like my y-intercept is right there. Well, what number is that at? Negative. I'm below the x-axis, so 1, 2, 3, 4, -4.5. So I'm going to put a minus 4.5. So that would be D. Okay, part E. Here's my graph for part E. Always label your x-axis, always label your y-axis, and then on the green piece of paper you're going to have to turn it over, and you can see that part E says draw Let's see if I move it up here so you can see it. Okay, there's E. So we're going to draw a line E and has a slope of 4. Now, if you notice in E, it just said, I just have to draw a line that has a slope of 4. It didn't tell me where it is anywhere. So what I can do is, I could just randomly put a point. I'm just going to put a point right here. And then I'm going to create a slope of positive 4. So that means I'm going to change in the Y, 1, 2, 3, 4. Change in the X, 1. So that's like 4 over 1. That gives me a slope of 4. And then I'm going to connect the two dots to make a line. So I could get this. Now the question is that the only possible line that I could have drawn that had a slope of 4? Okay, the answer is no. I could draw many lines. So for instance, if I started here instead of right there, and I did my slope triangle of 1, 2, 3, 4 for the change in Y, and 1 for the change in X, you could see I could get another line right here. So part E did not have one specific line that I could have made based on the information it gave me. So I'm done. There's no equation I write because there's more than one line. Okay, moving on to part F. Here's my y-axis. Here's my x-axis. Zoom out a little bit. And if you notice, part F says I'm going to make line F. It's going to go through the point 8, -1, and then it's going to have a slope of, and this is where there was a typo, hopefully you caught it, and I told you in class, it's going to have a slope of -3/4. Okay, so let's make line F. I have to plot the point 8, -1, so 1, 2, 3, 4, 5, 6, 7, 8, -1. So there's the point way over there. Went a little bit off my graph. And then from that point, I'm going to make a slope of -3/4. Now notice in this slope, there's only one negative sign. So that means one of these numbers is negative, but not both. So I'm going to treat it as if the 3 was negative, but the 4 was positive. Okay, or I could treat it as if the 3 is positive and the 4 is negative. All right, I'm going to do that one actually because that'll keep me on my graph. So from here, my change in my y value is going to be +3, so I'm going to go 1, 2, 3. And then my change in my x is -4. That means I'm going to go to the left 4. 1, 2, 3, 4. I'm going to stop and I'm going to put a point. And then I'm going to connect these 2 points with a line, and that's going to be my line for F. And then the question is going to be, okay, well, if this is my line for F, is this the only line that I possibly could have drawn that went through the point 8, -1 and had a slope of -3/4? And the answer is yes. So if you did F correctly, that's the only line you could get. So now let's write the equation. My equation would be y equals, well, we already knew our slope was -3/4, then we put the x, and then I'm going to put the y-intercept at the end. Okay, and my y-intercept, if you notice, is right there. So what number is that at? 1, 2, 3, 4, +5. So there's my equation for F. Y equals -3/4 x plus 5. Okay, last one for number 36 would be part G. Okay, so if you notice in part G, it said customer G sent the following table. Okay, so I've got this table here. It's got 1, 2, 3, 4, 5 values in it. So what I'm going to do is I'm going to plot 5 points on graph G here. Okay, so the first one I'm going to plot is 0, 1, over 0, up 1. The second point I'm going to plot is when x is 1, y is 2. X is 1, y is 2, right there. Sorry, I didn't label my x and my y-axis. There we go. The third point I'm going to plot is when x is 2, y is 4. X is 2, y is 4. The next point is when x is 3, 1, 2, 3, y is 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm not going to plot the fourth point, 4, 16, because it's going to be way off my graph. But you can see when I connect these points, I can't even connect them in a line. The only way to connect these points is by connecting them with a curve like this, and it actually will just keep going up. Okay, so G wasn't even a line, so I can't even write an equation for it. Okay, so that's how you would have done number 36. Okay, now we get to number 37. So number 37, if you notice, it says calculating the slope of a line without graphing. Now, keep in mind that slope is defined by the change in y over the change in x. And in math class, that's how we show the change in y. We put the triangle there. The triangle is the delta, is the letter, the Greek letter for the word delta. So really we would read this as delta y over delta x, which is the change in the y over the change in the x. Okay, so while determining the slope of a line that goes through the points 6, 5, and 3, 7, Gloria figured out that the change in y, delta y, is equal to -2. Oh, lights just went out. Hold on. Whew, just paid the PG&E bill. They're back on. And delta x, which stands for the change in x, is equal to 3 without graphing. Explain how Gloria could figure out the horizontal and vertical distances of the slope of the triangle without graphing. Okay, so if I were to answer A, here is how Gloria did it. How did she figure out the change in y, which would be the vertical distance, okay? Well, what she did was, if you noticed it, she took the y values, which was 5 and 7 from these points, and she subtracted them. So she went 5 minus 7, which is -2. Then to find the horizontal distance, which we call the change in x, which we represent by triangle, which is delta x. Notice she got +3. Well, how did she get +3? Well, she took the x value, which was 6, and she subtracted from it the x value, which was 3. So she got 6 minus 3 is 3. So that's how Gloria got -2 and +3 for the change in y and the change in x, okay? Then the second part of A said, draw a sketch of the line and validate her method. Okay, so if we were to sketch this line out, and whenever a problem says sketch, it means you don't have to use graph paper, but I'm going to go ahead and use graph paper for this problem to sketch it out so you can see how it works. Okay, so I'm going to get out my ruler. I'm going to draw my y-axis. I'm going to draw my x-axis, and what I'm going to do is I'm going to plot the points. Okay, so I'm going to plot the point when x is 6, y is 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And then I'm going to plot the point when x is +3, y is 7. So that would be 3, 5, 6, 7 right there. Okay, so, and then that's my line. Okay, so how did she get the change in y, the vertical distance, to be -2? Well, you can see she got it right here, -2. How did she get the horizontal distance to be +3? She got it right here. So that would be a sketch of it. Notice, there's my delta y, there's my delta x. You could get it by drawing what we call a slope triangle. Okay, part B, what is the slope of the line? Well, the slope of the line would be -2 over 3. That's what the slope of the line would be for that problem there. Okay, the slope of the line is always the change in the y over the change in the x. Okay, part C, use Gloria's method without graphing to calculate the slope of the line that goes through the points 4, 15, and 2, 11. Okay, so what I'm going to do in part C here is I'm just going to denote that x is 4, that y value is 15. Over here for 2, 11, x is 2, the y value is 11. I'm going to do exactly what Gloria did. So I'm going to take that y value, 15, subtract from it the second y value, which is 11. 15 minus 11 is 4. Then I'm going to put that over the x value, 4, subtracted from it the other x value, which is 2. And notice when I do this, if I use the 15 first, I have to use that 4 first for my change in my x, or my horizontal change. Okay, and that's +2. So I get 4 over +2. So that's what my slope would be. And I could do it without graphing. 4 over 2, and if we reduce that, that just becomes 2. So that's how you would have done problem number 37. Okay, last problem that, oh, we got a D and we got an E. Okay, so in part D, it says use Gloria's method to calculate the slope of the line that goes through the points 28, 86, and 34, 83. Okay, well, if I were going to do this, I'm going to do the same thing. To find the slope, I'm going to take the first y value, which is 86, and then from it, I'm going to subtract the next y value, which is 83. 86 minus 83 is 3. And then I'm going to put a fraction line, and then to find the denominator answer, I'm going to take the first x value, which is 28, and then I'm going to subtract from it the second x value, which is 34. 28 minus 34 is equal to negative 6. So that means for part D, my slope is equal to 3 over negative 6, and if I wanted to reduce that, that's going to reduce to negative 1/2. Okay? Part E, another student found the slope of part D, so they found this slope to be 2. What error or errors did the student make? Okay? Now notice, this is the slope. This student said the slope was 2. 2 is 2 over 1. So if you notice, what they did was they mixed up the numbers. The 2, which should have been the denominator, they put as the numerator. The 1, which should have been the numerator, they put as the denominator, and then they actually didn't even get the sign right. So I would guess the mistake that they made, was, and this is just a guess, I mean there could be other ones, they probably went 34 minus 28, right here, they went 34 minus 28, but then on the other side, the denominator side, they went 86 minus 83. So that gave them 6 over 3, which reduces to 2. Okay? Number 38, 2-38, steepest slope. What is the steepest line possible? Okay, well the steepest line possible would be this line right here. Okay, and if you recall in class, that's called a vertical line. So the steepest line possible is a vertical line. You can't have a steeper line than that. Think about like climbing a mountain. I mean, if the mountain's like that, you can't get any steeper than that. That's like El Capitan right there in Yosemite. Okay, what is the slope of this line? All right, well, the slope, if you recall, is actually of this line, it is actually undefined. So there is no slope. You cannot find the slope of a vertical line. Okay, then it says be ready to justify your statements. So, because, why is the slope undefined? Here's why. Let's say that I want to find the slope between those 2 points. And let's say the change was positive 4. Okay? Because for this example, the vertical change would be positive 4. Remember, slope is defined by vertical change, or delta y, over horizontal change, which is delta x. Okay? But how much does it change to get from that point to that point horizontally? It doesn't. It's 0. Okay? So my slope would be 4 over 0. Okay? And this problem right here, you can't ever have 0 in the denominator. Okay? So this is undefined, because 0 is in the denominator. You can't have that. Okay? So there's your answers right there. If you have questions in class, come and ask.